Hi, I'm Guang, 50 years old. In this lesson of techniques and applications of definite integration, we are taking a look at this example here. So in this example, we will have to determine the volume of the solid that is inside the cylinder x squared plus y squared is equal to 16, below z is equal to 2x squared plus 2y squared, and above the xy plane. So what will be so special about this example? Now if you try to imagine it, you have an xy plane and you have z is equal to 2x squared plus 2y squared, which is the paraboloid, and then you have the boundary of x squared plus y squared is equal to 16, which is an infinite tall cylinder but a radius of 4. Right, so that will be what your boundary looks like. It will be within these three surfaces. Alright, so now that we know what it looks like, we can choose to use different methods to solve it. And in this lesson, we'll be taking a look at, well, probably two of the methods. So, the first method, it is one of the most classic, basic methods you might use, where you just have Cartesian coordinates. And so, by using Cartesian coordinates, again, you can actually think about it in two different ways. Well, the first way, of course, z inside here, since your height originally is from 0 to z, so you could just change it into a triple integration, but with an extra dz, where z will be from 0 to 2x squared plus 2y squared. While here, you can also once again choose dx or dy first. So those are already a few different variations. So let's say you want to choose dx first. Then what you will have is from negative square root 16 minus y squared to positive square root 16 minus y squared. Well, for y, you're going to have from negative 4 to positive 4. So that is one of the ways you can think about it. But if you know what this looks like, they'll actually have the same amount of volume in all the four quadrants if you look at it, ignoring the z-axis, just the x or y plane. If you look at it, you have four different quadrants on the xy plane, and in each of these quadrants, since they do have the same amount of volume, you could also change this into 4 times and then integrate from 0 to 4 and then integrate from 0 to square root 16 minus y squared. Alright, well, you could choose to write that once again, or you could also just directly integrate it. Alright, so from this, what you will then have is just to integrate it. So by integrating this, what you actually have is 8 over 3. Since both of them have 2's, you could take the 2 out to multiply with the 4. So 8 over 3, integrate from 0 to 4. Then you will be having, well, actually this over 3, it depends on you. You can choose to take it out, you can choose not to take it out. But it is mainly from your x cubed, alright? Since when you integrate an x squared, you have a 1 over 3x cubed. But then, if you want to do that, you have to be aware the part behind needs to come with an extra 3. Since when you're integrating with respect to x, you take y's or even z's and other variables as constants. Right, so this is what you will have. Then you just have to substitute in 0 and square root 16 minus y squared. And then, of course, dy. Right, so this will now be what we are taking a look at. So with this, what we will have is 8 over 3 integrate from 0 to 4 square root 16 minus y squared then cubed plus 3y squared square root 16 minus y squared and then dy. Alright, so how are we going to solve this part now? So in this portion, we are going to make a same substitution for both of these terms. And this substitution is going to be a trigonometric substitution. Well, we'll have to let y be equal to for either sine or cosine, and then choose whatever variable you like to put there. So let's say y is equal to 4 sine t, where dy is going to be 4 cosine t, and the range for t is going to be from 0 to half pi. Alright, so that is what you will be seeing. Right, so next you'll just have to put in the substitution, where you will have 8 over 3, of course it will actually be multiplied by something. It's just that you have to find out what this something is. Well, you could just find it by, so dy, you have a 4. For each of these terms, in the first term, you're going to have 16 square roots and then cubed. Or for the second term, you're going to have 4 squared and then a 16 square root. Which actually, for both of these terms inside, you are going to have a 4 cube coming from them. Alright, so with that, you just have to multiply it by the 4 behind, where you have a total of 4 to the power of 4 coming out. Well, that is 256. And then you just have to integrate from 0 to 4. So within here, what does this become now? So 1 minus sine squared t, that's a cosine squared t, which makes it a cosine cube t, and then plus 3, so y squared, they're going to have sine squared t, and behind just becomes a cosine t. And overally, you would have to multiply this by a cosine t dt. Right, so this is what you will have to solve. Now you can multiply the cosine t into them, and each of them using a different double angle formula. But of course, you can also choose to use the same double angle formula, but that depends on you once again. So you could bring a 4 in to both of them. So why exactly a 4? Well, in front here becomes times 64. So when you bring a 4 in, your cosine to the power of 4t, it can become 1 plus cosine 2t squared. Alright? So this is actually what the first term becomes. Or for your second term, you're just going to have plus 3 sine square 2t. So, which is why you have a different double angle formula. The first one, you use the double angle formula for cosine. The second one, you use the double angle formula for sine. And now, you can choose to expand it. And of course, for the second part, you are going to once again use a double angle formula. So, let's take a look at what will this become. Now, depending on how you like to solve it, you could separate them in different ways. Whether you want to separate it into two terms, where you're going to have 512 over 3 integrate from 0 to 4, 1 plus 2 cosine 2t plus cosine square 2t, and then dt. Then you add on 512, which you need to bring a 2 in for your double angle formula, and that becomes 256. Integrate from 0 to 4, and then sine square becomes your 1 minus cosine and the double angle, which in this case it is 4t. Right, so this is what you will be seeing. Now, the first part and the second part of the first term and the entirety of the second term are actually solvable, which means you're left with the last part or the third part of your first term, which in this case you're again going to use a double angle formula. So let's take a look at what the rest of the parts will give us. Wait a minute. T. Sorry, I forgot to change the boundary of this T. I'm just going to change it real quick. it is from 0 to half pi. Be aware of that, it is not 0 to 4. Sorry about that. Alright. So this is what we have. This should be right now. Okay, we'll take a look at the first term. And we're going to have 512 over 3 t plus sine 2t. Substitute in the values of 0 and half pi. And then you add on 256 over 3. Integrate from 0 to half pi. 1 plus cosine 4t dt. And then in your second term, you're going to have 256t. I'm actually going to write this better, so plus 246 over, there's no over 3. Then you're just going to have t minus sine 4t. Substituting the values of 0 and half pi. Right, so this is what we will be dealing with. Now take a look at the first term. We're going to have 256 pi over 3 minus 0 plus 0 minus 0 plus 256 pi over 3 linear over 2. So, or you could just leave this as 256 over 3. Then you have t plus 1 over 4 sine 4t. And yes, there is a 1 over 4 here. So then you have to put in the values of 0 and half pi. And then you have to add 128 pi. So afterwards, what you will just realize is here, when you have 256 pi over 6, well, I'll just write that out. You could choose to simplify the 2's, or you could just realize that these 2 actually adds up to become 128 pi, which will give 256 pi in the end. Right, so this should be your answer for this question. So this is just method 1. Now how about let's take a look at method 2, since method 1 is just a Cartesian coordinates. Now in method 2, what you're actually going to have is polar coordinates. So what will be so special about Cartesian coordinates versus polar coordinates? Now let's take a look at this. So initially you have 2x squared plus 2y squared. Well, you can change that a little bit to make it become 2r squared. Since now you're using polar coordinates, now dx dy becomes r d theta. Alright, so now your r, the range for r is from 0 to 4. If this is from 0 to 4, then this, since this is 0 to 4, this will be from 0 to 2 pi. Or you can also change this into 4 separate quadrants. So now we take a look at this. We have r cubed dr. So 2, or if you can realize it immediately, that will be over 4, which is a half. So you have half r to the power of 4, substitute in 0 and 4, and you have to multiply theta, substitute in the values of 0 and 2 pi. So that means you have 4 to the power of 4 pi, if you can realize that fast enough, which is actually a much faster method of directly obtaining your result of 256 pi. So in this method, you'll realize it's actually a lot more simpler than the Cartesian coordinates. Since you will realize there is no theta within the integrand, you can integrate the theta directly, and well, it's just a simple integration with respect to r. Should be learned in like normal classes, whatever. So afterwards, you just have to do a little bit of mental calculation in order to get 256 pi. So two different methods. You just have to determine or even instinctively know which method should be better. Since this is within a cylinder, most likely it is going to be polar coordinates. but I only said most likely since sometimes the polar coordinate can be actually a lot more complicated. Well, that just depends on what kind of integrand you have, how you choose your integration and all, okay? So this will be the two methods for this example. Alright, so take a quick look at all of these. And I'll be ending this here. So thank you for your watching.